Welcome back, guys. Today we'll look at paper 2 of the February-March 2024 series, and as with paper 1, this is also 1 hour 45 minutes. Question 1, it says tick one box to show which task is part of the analysis stage of the program lifecycle. Now, if you just remember the letters, right, so I think the first one is going to be A. If we look at the program lifecycle, right, or software development lifecycle, right, then it's going to be D, then it's going to be C, okay, then it's going to be T. And I mean, sometimes we also say M. I think this is more for A level. I think for IG, they generally don't include this. Okay, so, well, A, then that's going to be analysis, right? D is going to be design, C is going to be coding, right? T is testing, and then, M is going to be maintenance. Now, if you can just remember those letters, that's fine, right? Otherwise, I do actually have this acronym. So, you could use all dogs can track, right? So, analysis, design, coding, and testing. I also use ChatGPT, and I think this one is also quite good, right? Always double check twice, and you can pause it, right? Use some of these if you want. Although these are a bit longer. I mean, if anyone does have a good acronym, then leave it in the comments as well, all right? And then maybe that can help other people. If we look at this question, so we want to say what task is part of the analysis stage. Well, the thing is, I mean, this graphics tablet is really annoying. I mean, coding, right, this is actually one of the other stages, so let's discount that. I mean, decomposition, right, maybe. Design, again, that's also another stage, and testing, okay, this is also another stage. So I think here it makes sense to say decomposition, because, I mean, during the initial analysis, well, obviously you're going to be decomposing the problem into the, individual sub-problems, all right, and this can also include things, stepwise refinement, that's another one, where you break down the task into, let's say task 1, right, then task 1.1, 1.2, maybe, 1.21, 1.22, all right, etc. Question 2, right, 4 test data types and 5 descriptions are shown. We want to draw one line to link each test data type to its most appropriate description. And I think what I'm going to do, right, I'm actually just going to do B first, because I think we can sort of combine these. Right, I mean, this one, because here we actually want to give an example, and then with an example we should be able to, match the descriptions if we don't know. So here, an algorithm has been written to test if an integer that is input is in the range 5 to 10 inclusive. Identify an example of suitable test data for each test data type. I mean, so abnormal, I mean, this is just anything that's invalid. So, for example, we can say 11. I mean, for this we could also say, well, let's say 4, obviously we can say like minus 999, right? We could even say like a, string, maybe ABC, right? Although for here, I mean, let's only use 1, okay? So, we can just use 11, that's fine. Right, boundary, so here there's actually going to be 2. I mean, there's going to be the lower bound and also the upper bound. And then for each of these bounds, the bounds actually have sort of 2 data values as well. Right, so the boundary, is going to be the sort of closest, let's say the closest abnormal, right, and then also, let's say the closest, let's say the closest abnormal, right, and then also the extreme value. So in this case, 4 is not going to be accepted, okay, but 5 would be accepted. So this would be the boundary, because if we think about this, you can sort of draw a line, right, where, anything kind of left of this is abnormal. Right, anything right of this, that's going to be sort of valid. Of course, there's also an upper bound here as well. And if we want to do the upper bound, that's going to be 10, right? So 10 is going to be the extreme value, and then 11, right? That's going to be the that's going to be the abnormal value, right? But again, I think in this case we only have to list 1, right? So let's just list this 4 and 5. I mean, you could probably do 10 and 10 and 11 too if you wanted. Right, extreme, like I said, this is going to be the sort of smallest that's accepted and also the biggest that's accepted. So in this case, we can just say 5, right? We can also say 10 as well if we want. But I mean, here it does just say an example, okay? So I think we just need 1. And then normal, this can just be like 7, right? So anything that's also accepted. And I mean, I would say technically, I mean, I think 5 and 10 would probably also be considered normal, because, they're also valid. But I guess really for this, probably go somewhere between like 6 and 9. So yeah, just somewhere, you know, in that kind of definitely safe range. Right, and then if we go up, this should be quite easy now to match these. So abnormal, well, abnormal is going to be a value that's rejected. Right, then if we go to boundary, so I think, yeah, this should be number 2, okay, a value that is the highest or lowest value to be accepted, and the corresponding lowest or highest value to be rejected. Because again, for each boundary you have, you know, one that's accepted, one that's not accepted, right? Or if you're using these words, you have one that's one that's abnormal and one that's extreme. Right, so extreme, then this will be the highest or lowest value to be accepted, and yeah, okay, normal, right, that's going to be this one here. And then I guess, yeah, this one just has no definition, or kind of, yeah, no matching data type. Right, the next one, so a linear search and bubble sort are standard methods of solution. 50 numbers are already stored in the array, values 1 to 50. Okay, right, we want to write an algorithm in pseudocode to input a number, right, that's called myNumber, and use linear search to test if that number is stored in the array. If the number is found in the array, the position in the array is output. And if the number is not found in the array, then not found as output. Right, so what I'm going to do, I'm actually just going to copy this, and then, yeah, I'm just going to write it on the website, just so then we can actually test it. So I mean, here, you know, you can go here to the exam questions, right? You can then, you can then find this starter code. In fact, hang on, sorry, not solution. Let's go open in code editor. Right, and then I'm just going to paste the instructions here, okay, just so I can see them again. Right, let's also maximize and, yeah, make the text bigger. So, I mean, this here, right, this is what Cambridge would have already declared. So, you know, we don't need to write this again. Right, so the first thing we want to do, right, we want to ask them to input a number. So let's just go output, and yeah, I mean, let's just say input a number. Right, then we're going to input this, and we're inputting this into myNumber. Okay, this has already been declared. Right, then we want to use linear search to find it. So let's go here and declare. Now, I think, you know, sometimes Cambridge say we don't need to declare, although I would say it's safe, you know, if you always just declare anyway. Because I mean, yeah, it's better to declare and it's fine, rather than to, you know, not declare and then, yeah, they say that you actually did need to for this particular question. So I guess, I mean, one we're going to need is a boolean, right, determining, you know, if the number has been found or has not been found. And then if we're going to use a while loop or repeat until, then we'll also need an index, right? Because if we have a for loop, well, the index is kind of included, you know, like for n, and then assign like 1 to 50. But I guess, yeah, here we actually need to create another index, right? So the index is going to be integer. And I mean, the reason we can use either a while or repeat until is because we want to stop the loop as soon as we find the number. Whereas if we have a for loop, I mean, that for loop is going to repeat 50 times. Like, even if we find the number in the first instance, right, or the first index. Yeah, so that's why we want to stop as soon as we find it, right? And to do that, we can, maybe let's just go found, and let's make this a boolean. Now, let's say the index, right, this can start at 1. Okay, found we're also going to assign to be false, because obviously, well, you know, at the start we've not found it. Right, then what we want to do, let's say while, and the condition, well, we want a loop, right, while found equals false. But then we also need another condition, right, checking the index is less than or equal to 50. Because, yeah, otherwise if it gets to 51, right, then we're going to get a kind of out of bounds exception. Right, I'm just going to do the end while there. Right, okay, so yeah, here then we can just check the current, let's say we can check the current element, okay, with this myNumber. So is it called, yeah, what is the array? Okay, the array is called values. Right, so let's go if values, and this will then be index, and we want to check if this is equal to myNumber. Right, if it is, well, then I think there's, well, I mean, yeah, one we just want to go found, and that can be true. And I mean, yeah, I think that's all we really need to do, because we can just output. So when it says here, yeah, output the, you know, when it says, yeah, output, Okay, so alright, I think what I'm going to do, I'm actually just going to output that here. So here, let's just output the position, right, or the index. So, I mean, let's actually just go my number, right, and then we'll just go found. Let's say found at, and then we'll go index. And the reason I'm going to do it here is because, well, after this, we're then going to go index and just increment this. And I wouldn't really want to output this after, because, for example, if we then do something like this, let's go, right, if found equals true, I wouldn't then want to go output index here, because of course now the index is going to be one higher than, you know what, than the position we found at. Now, of course, we could go index -1, but I guess, yeah, that's just sort of more effort than we need to do. All right, so I think, yeah, just outputting here should be fine. Right, so let's actually change this then, right, if found equals false, and then we just output, is it not found? Yeah, okay. And is that, okay, yeah, lowercase. Right, and yeah, then if we just go end if. Okay, so I think that should be fine. I mean, let's just test it. Right, so actually let's check what number is there. Let's say, for example, 97. So yeah, 97 found at 2. I mean, like, I'm not really sure what number is not there, maybe 5. Yeah, okay, then it says 5 is not found, okay, which seems to be correct. I mean, let's also try the last index just to check this is working. So let's go 87, and yeah, 87 found at 50. Alright, so this seems to be working. Right, if we go to the next question, write an algorithm in pseudocode to sort the array values 1 to 50 into ascending order using bubble sort. So I'm just going to use the same one here, and yeah, let me just delete all of this. I'm also going to delete those comments. Now, if we've got bubble sort, I mean, you can even do the unoptimized or you can do the optimized. However, if we look at this, I mean, this is 4 marks, so yeah, maybe they don't require us to optimize. Although I think really, again, you know, it's better to optimize just in case, because if they give you 2 marks for that, well then of course, yeah, it's better to have included it. Right, so if you're not familiar with bubble sort, I mean, I've got a more detailed video covering this. Yeah, the video is the kind of IG entire syllabus video, and that has like a 15-minute description of bubble sort. But I mean, let's kind of sort of assume that people know how to do this already. So I mean, the first one we can go maybe did swap. All right, that's going to be a boolean. Right, then we're also going to declare the end index. Right, that's going to be an integer. So here then, well, let's say did swap, and we'll just assign this to true. And I mean, the thing is, you know, you could use did swap, and of course, well, that's going to be true if they did swap, right? False if they didn't swap. You can also kind of invert the logic, where you could call this, for example, is sorted. And then you go like, right, is sorted, so this will be false, right? Because we're going to assume that this is not sorted. And I mean, I don't know, like maybe some people find this easier to understand, right? Or some people might find, you know, the did swap sort of one easier to understand. I mean, it doesn't really matter, to be honest. Right, so yeah, I guess then what we want to do, we also want to assign this end index to 50. Okay, sorry, 49. Because what we're doing is we're comparing, well, you know, up to element 49, and then 49 will compare with 50. Right, if we make this 50, well, then it will try to compare elements 50 and elements 51. But, you know, element 51 doesn't exist in the array. All right, so yeah, that's why it's 49. And then what we want to do, we want to go, well, while is sorted equals false. Right, then what we want to do, let's just go end while. Right, so inside here what we should do is we should set this is sorted to be true. So this is kind of like assuming that the array is sorted, and then if we have to swap, well, then we set is sorted to false. Right, so here then we can just have a for loop, and let's say maybe index. Right, so this will be 1, and then we'll go to the end index. Right, let's here just go next index. And then here what we want is we just want to check, yes, we want to check if the current element is bigger than the sort of element plus 1, right, or the index plus 1. Right, so let's go if values. Okay, this will then be index, and check if this is bigger than values and then, well, the index plus 1. Right, then if it is, well, let's declare a temporary variable. That's going to be an integer. And then so here we just want to swap these two values. Right, and the way we can do this, if we just go temp, right, let's assign this values and then the index. And I mean, this one I always mess up, to be honest. Right, so if we assign that, then we want to assign index plus 1 into the index. Okay, so let's go here, right, values index, and we'll then just copy the index plus 1 into there. Right, and then what we want to do, we just want to assign this temp, right, to the index plus 1. So that's going to be values index plus 1. And yeah, we'll just assign this temp. Right, I think that should be okay. And I mean, let's also remember to set this is sorted to false. And yeah, let's also remember just to decrement this end index. Alright, now, yeah, I think that should be okay. I mean, of course, right, this next part you don't have to do. I'm just going to add a sort of, yes, comment separator. But let's test it works, right, just by outputting these numbers. So if we just go 4, right, let's go 1 to 50. Then we're just going to get output. This will be values index n. Right, and then if we just go like this. Okay, and yeah, it seems I forgot the end if. Yeah, I mean, that seems to work. Yeah, okay, alright, so this seems to be working. And again, you know, I would say, like, once you write your solution, okay, just go through and check you've got, like, all of those end ifs, the end whiles, you know, make sure you've declared, you know, just all of those simple mistakes that you can easily make. Yeah, just make sure you don't do any of that. Right, so then we want to identify 3 data types used in programming. So this one should be quite easy, right? You've got, well, string and char, right? So they would be the sort of, you know, sort of character text types. For the numbers, you've got integer and real. And yeah, let me just write these. Okay, hang on, yeah, let me select the draw, okay. Right, so here we can say string. Right, we can also say char. And then, yeah, for numbers, well, I mean, I guess you can put these in capitals if you want. Right, we can then go integer, okay, we can also go real. And then, yeah, we can also go boolean. Right, so for IG, there's only those 5 types. Yeah, that's all you have to remember for IG. Right, the next one, an algorithm has been written in pseudocode to calculate the profit when an item is sold. Values for cost price and selling price are input. The profit is calculated selling price minus cost price, right, and then that's output. Then the input of 0 for either value stops the algorithm. Right, we will identify the line numbers of 3 errors in the pseudocode and suggest corrections. Right, so if we just read through this quickly, well, right, we're going to repeat, and we're repeating until the cost equals 0, right, or sell equals 0. So yeah, that seems probably okay. Right, and then if we look at line 2, well, output, enter cost price, I mean, this seems okay. Right, input cost, yeah, that seems okay. Right, then we have, well, output, enter selling price, yeah, that seems okay. But then here, if you look at this, well, then we have output sell. Right, but I think, yeah, this one should be input. So, right, this one is going to be line 5. And then, yeah, let's just write this. So that's going to be input. And, yeah, we're going to input into this sell variable. Right, if we look at the if statement, it says, right, if cost is not equal to 0 or sell is not equal, or sell is not equal to 0, right, then we're going to, well, then we're going to do sell minus cost, which is the profit. So, yeah, that seems okay. Then output profit is, and then profit. So I think, yeah, lines 8 and 9, they seem okay. But then if we look at this line 6, right, the if condition, I mean, let's just read the description again. So, right, the input of 0 for either value stops the algorithm. Okay, so the problem is, like, imagine if, I don't know, maybe the cost is 5, right, but a sell is 0. Now, in this case, right, this one is going to be true. Okay, well, you know, this one is going to be false. But if we have true or false, right, this is actually going to go here, right, into the profit. So effectively, right, we want to make this and, because we want, well, the cost should be not equal to 0, yeah, and the sell should also be not equal to 0. Right, so let's go, well, line 6, and then, I guess let's write the whole thing. Right, so if cost, right, that's not equal to 0, and then, yeah, just write and. Okay, cell is not equal to 0. Okay, yeah, cell. Right, and then I think line 3, if we just look at this next, well, right, this should be an end if, because, yeah, there's no for loop. So, right, that's going to be, yeah, 10, and let's just say end if. And I mean, that was the same mistake I just made as well. So, yeah, it's quite easy to make that mistake. Right, it says the algorithm needs to be improved with a range check. Write pseudocode to reject the input values less than 0 for variables cost and sell. So what this is saying is, well, basically, yeah, I mean, we don't want to calculate the profit, if either sell or cost is negative. So the way we can rewrite this, and I think I'm going to have it split screen, right, because it is kind of easier to see this, and type the code at the same time. And obviously, I mean, if you're in the exam, right, one is on one page, one is the other page. So yeah, you should be able to see them at the same time. Okay, I've just gone and split screen it just so it's easier. Now, I think then what we want to do, if I just annotate this, I think basically it's asking us just to kind of rewrite these 4 lines here. And of course, yeah, remember this one should now be input. So yeah, it's just asking us to kind of rewrite these, right? But with the condition that it's going to keep asking the user to enter, until the values they enter are not negative. And yeah, actually, yeah, let me just check. Does it say not negative or specifically greater than 0? Yeah, so I think entering 0 would be okay. Because again, 0 is just going to terminate the program, right? So we only need to check if it's if it's not negative. Right, so here then let's just use a repeat until, and we'll then just copy this. So let's go output. Right, this will then be enter. Right, enter cost price. Right, then let's go input, and here we're just going to input into cost. And I mean, okay, for me, I'm just going to declare them just so I can test them on the website. Right, however, obviously in the exam you don't need to declare them. And I suppose these could be an integer, but probably they could also be a real. If we're assuming it could be a sort of decimal price. And then what we want to do, well, let's go repeat until, and this should be until cost is greater than or equal to 0. And then, I mean, honestly, I'm just going to copy that just to save time. Right, and then the next one, that should be, let's say, selling price. Right, input a sell, and then, yeah, until sell is greater than or equal to 0. And if we just test that, all right, let's make it full screen. So I mean, let's say, for example, -1, all right, that's going to say invalid. Then if we try 1, okay, that's okay. All right, now it says selling price. And if we enter 0, so 0 should also be accepted. Because if you remember, if they enter 0, well, let's just move this across, hang on. Okay. I mean, if they enter 0, well, that's going to be accepted, because then it's going to go to this until, and it's going to terminate this kind of out, it's going to terminate this outer loop. Alright, so I think that should be okay. Right, then we want to describe 2 other validation checks that should be included in this algorithm. So I think here, I mean, one can be a data type. So yeah, let's just say type check. And let's say, to ensure the input, I mean, let's say, yeah, is real, or we could say, right, or integers, or maybe let's say or integers if cost and sell have to be whole numbers. Okay, yeah, that should be fine. Now, this question is honestly a little bit weird because, I mean, pseudocode doesn't even provide a way really to, I mean, well, certainly not for IG. IG pseudocode doesn't actually provide a way to check, is it a string, is it an integer? And the way that the input works is like whatever value, or sorry, whatever data type you declare that variable, well, the input will then try to be converted to that data type. So for example, let's say if you declare, I don't know, maybe temp. I mean, well, let's just do this right on the Pseudocode website. So let's go declare, we'll just call it temp, right, and we'll say this is a string. Then let's go input, and yeah, well, let's just input into temp, and then maybe let's go output, and we'll just go length of temp, right? So here, because we've said, this is a string, then whatever we enter is also going to be considered a string. Yeah, that's why, we can use this length here, and it's going to work. So let's just try like 1, 2, 3. Okay, it says the length of string is 3, because if you think, right, that's actually considered a string like this, okay, the string 1, 2, 3. Now, if we make this an integer, well, in this case, this length is not going to work. And yes, it's invalid argument 1, 2, 3 specified, because effectively this is an integer, right? But this length is going to, this length is going to expect a string. So, yeah, that's the thing that's kind of weird about this question, that in pseudocode, there's actually no way to check the data type anyway. But yeah, I guess that's what they're looking for. And I think the next one we can probably say, I mean, well, we've said range check. I mean, others are not really relevant, okay? So I think the only other relevant one is going to be presence. So yeah, let's just write that. Okay, presence check. And right, this is going to be to ensure. Right, so basically to ensure that 2 values have been entered. Right, so let's say to ensure that, values, right, have been entered. Entered for both. Let's be specific, right? So let's say cost and cell variables. Although, to be honest, I also find this one a bit strange because, I mean, if we're doing a type check, then a type check really should also be checking, for the presence. Like, if it's just empty, well, empty is obviously not going to be a valid number. Like if they just, sort of enter an empty input. So, yeah, I guess this one is also a bit strange. But I think this is what they're looking for, all right, type and presence. Right, then we want to describe 2 types of iteration that a program can use whilst writing a program. So let's see the first one. I mean, well, so here they've already mentioned, if we look, I mean, here they've mentioned repeat until, so that's going to be a post-conditional, right? So I think we can probably mention the other ones, right? Although you could also mention a post-condition, because, I mean, here it actually doesn't say 2 other types. But anyway, for me, well, let's go count controlled. Right, count, yeah, controlled. Yeah, I mean, I'm just going to type because this thing is really difficult to write with. Right, so a count controlled, I mean, that's going to be a for loop. So let's say e.g. a for loop. And then if we describe this, well, we can say this will loop, for the number of times specified, right, from the start index to the end index, right, and then also, sort of using the specified step value. So let's say, this will be, let's say guaranteed, guaranteed to loop, right, let's say the number of times, right, specified. Yeah, by the start index and end index, or maybe the start index, right, end index, right, and step values. Yeah, and I mean, I guess here, I mean, we could give an example, although, yeah, I don't think it's really necessary. Right, the next one, let's go for a preconditional. So e.g. a while loop. Let's say a while and then end while. And then, well, here we can say, right, this will loop while the condition is true, right, or whilst this initial condition is true. And I mean, I'm actually going to be a bit more specific. So let's say it's going to be while, then there's going to be a condition, right, and then there's going to be a list of statements. So let's just say statements. Right, so let's say, right, this will loop. Right, yeah, this will loop while the, right, and then let's just say condition, right, is true. Yeah, I don't know, let's say, right, performing these statements, right, on each iteration. And then I think the thing with a preconditional is, well, if the condition is initially false, right, then it's never going to execute. So let's say, yeah, if the initial condition is false, right, then the, let's say, statements inside the loop will never be executed. Yeah, so I think that should be fine for this one. And I mean, if you did also want to do the post-conditional, well, then if you're using a repeat until, you'd say, well, that's gonna, that's gonna execute those statements, right? It's gonna do the iterations, yeah, while the condition is false. Okay, because yeah, it's gonna do it until it's true. So effectively, yeah, that means it's gonna loop while it's false. And then, the difference, of course, you can say, well, a repeat until, right, or a post-conditional is always going to execute at least one time. Whereas, yeah, a preconditional might never execute. Right, the next one, so we've got this logic expression A, XOR B, and B and C. Right, then we, okay, let's draw. Right, then we want to draw a logic circuit for this logic expression. Each logic gate must have a maximum of 2 inputs, and do not simplify this logic expression. Right, so if we go here then, right, this is going to be, yeah, XOR B. So if you remember, well, XOR is just going to be the extra one, right, then it's just going to be the OR. Yeah, okay, so that's my XOR, right, probably not the best. Right, then what we want to do, not B, because this AND is going to come at the end, right, because yeah, this is going to AND this one and this one, so of course, yeah, we do these first, right, then do the AND at the end. Right, then we want to go not B, so let's have, right, the triangle, yeah, with the circle for a not, and then right here, well, we just want a yeah, we just want an AND, so the AND is just this D. Yeah, okay, right, then we just want to AND them together. Okay, so yeah, I think that one should be fine. Right, then we just want to, yeah, write the truth table. So what I'm going to do, I'm just going to write those here quickly, and yeah, maybe I won't have enough space. So right, this is going to be A, and right, I'm just going to use these symbols because it's quicker, or kind of shorter. Right, so this one means XOR, and for A level you can use these, and yeah, for IG, probably they would also accept this. Alright, so yeah, A, XOR B. Right, then what we want is, well, not B. So not B, we just write with the bar. Right, then let's go not B and C. Alright, so actually, alright, so and is just the dot. Okay, so let's go and C. Yeah, then we just want to do all of it together. Alright, so that's going to be A, XOR B. Right, then we want to go and. And I suppose this one we don't really need to do, okay, because, well, that's just this X value. Alright, so yeah, let's try and do this then. If we have XOR, when they're different it's going to be 1, okay, when they're the same it's going to be 0. So yeah, 0 XOR 0, 0, alright, 0. Here they're different, okay, so it's 1. Right, yeah, different, different, different. And then here they're the same. Okay, so that should be fine. Right, then if we go not B, well, yeah, not 0 is 1. Of course, right, not 1 is going to be 0. And, I think especially with this kind of easy ones, when it's just 1 or 2 inputs, usually you're going to get some sort of symmetrical kind of pattern. Like here we see B, right, it goes, yeah, 1, 1, 0, 0, 1, 1, 0, 0. This one was, we've got 2 zeros, right, then 4 ones, right, then 2 zeros. So, if you get some weird thing, like if you get maybe 0, 0, 1, 0, yeah, I don't know, like if you get something like this, this probably means you've made a mistake. Now, when it gets to, the final answer, of course, yeah, then it can be sort of like this. But, when you just have simple sort of, like 2 inputs, right, you're probably going to get some nice, like, symmetrical output like this. Right, so then we've got, well, not B and C. And I mean, this one is getting more, a bit more complex. So yeah, possibly this won't be as sort of symmetrical. Right, so not be, right, so here we've got, well, so I mean, here we're looking at this column, right, so 0 and 1, well, that's going to be false. Then we've got 1 and 1, okay, that's going to be true. Right here we've got, yeah, 0 and 0, right, that's going to be 0. And to be honest, what I like to do sometimes is I like to look for the ones that are true, so we can see, well, this is true, and just fill in all of the ones that are true, okay, and then just go back and fill in all of the ones that are then false. Yeah, no, I think that's kind of quicker, and for me probably less error prone as well. Right, then we just want to do the whole thing. So right, I mean that's going to be, well, so this column, right, and then just and this column. So if we use that same logic, well, look for the ones where we've got 1, 1, right, that's going to be this, and then yeah, everything else is then going to be false. Right, and of course, sort of writing the answer, well, we'd obviously write these in here. Okay, so I think this should be okay. Right, the next one, this flowchart represents an algorithm to find the average size of groups of visitors to an attraction. Right, first of all, we start. Right, then we assign 0 to number of groups, also 0 to total. Right, then we input the group size. Okay, and yeah, we just need to complete this we need to complete this trace table. I mean, these are a bit complex because people always ask, like, when do you start a new line? Or, when do you start a new row? And to be honest, for Cambridge, it seems to be different every time. But I think here, if we think, well, let's just assign this to be 0, this to be 0, because, that's going to be this one here. Right, and then, I mean, if we look at this, right, then we're going, then we're sort of going inside this loop. Because, I mean, we see this loop here, right? Now, when we're starting a loop, usually that means we're going to start a new row. Okay, so yeah, when we input this group size, well, first it says we input 7. All right, so yeah, that's these values here. Right, so we say, well, is group size equal to 0? Okay, that's going to be no. So then we increment the number of groups. So right, this goes to 1. And then we will say total is, well, total plus group size. Okay, so this is going to go to 7. Right, so then we go 10. So right, 10 here, again, then we just increment this goes to 2, all right, then we just plus these, so I guess that goes to 17. Right, then we input 2, all right, so this is going to go to 19, this is going to go to 3. Right, then we input 8, so this will go to 27. Yeah, that's going to go to 4. Right, then we go 3, so that should go 30. Yeah, this also goes 5. Yeah, let me just move it down a bit. Right, okay, then we get the next one, so that's going to be 9. Right, this then goes to 39, this goes to 6, and then, okay, so the next one is 0. And then if we look, so here we have this if statement, right, this, diamond condition, right, we say is group size equal to 0, yes. So then what we want to do, we want to do average, that's going to be div, well, total, and then number of groups. So, right, that's going to be 39 div 6. Now, if we think, I mean, that's going to be, 6.5? Because I guess we say, well, 36. I mean, let's say like 36 divided by 6 is going to equal 6. Therefore, 39 divided by 6 is going to be 6.5. Right, but because we're using div, then we're just, cancelling this decimal. So I guess, yeah, here, let's go 6, and then, right, okay, so then we just want to write this. Yeah, I'm going to move it down because, again, this graphics tablet doesn't really work at the bottom of it. Right, so we just want output, so average. Right, yeah, average group size. Right, and then, yeah, okay, and I guess, then we just go 6. And I think, I mean, here, like, maybe we don't need these quotes, but I think, yeah, I'm going to include them. All right, that should be fine. Right, so question 9, a storage unit rental company wants to set up a new database table for these storage units that can be rented. The table is called storage units and needs to store these details. Right, size, so size in square meters, the position, first, second or third floor, the hoist, whether there is a hoist available for the transfer of items. And I mean, if people don't know what hoist means, I guess this is just saying something to lift the items. Right, so because yeah, you know, the items, they're going to be heavy, right? So they need like a crane or some hoist in order to lift it. Right, then price month. So the price in dollars for a month's rental, and the storage ID, that's the code to identify each storage unit. Right, for example, S123. Right, so if we note here, well, this is going to have to be a string, okay, because it's going to contain you know, sort of character. Well, it's going to contain letters, right, and then possibly also numbers as well. Right, we want to give the name for the field that would be used for the primary key. So because here it says to identify each storage unit, well, that's going to be this storage ID. Right, state the reason for choosing this field as the primary key. And we can say, I don't know, like because, I don't know, it's stated, that this field can identify each storage unit. Right, so because it's stated that this field, alright, and I'm just going to put in brackets, right, uniquely. Because although here, I mean, it actually doesn't say uniquely identify, although I guess that's probably implied. So yeah, because it's stated that this field can uniquely identify. Yeah, or let's say uniquely identify like each row, right, or each, let's say each record, each tuple. So yeah, I think tuple, that's the word they use. But tuple, I mean, basically it just means like each row in the database, right, or yeah, each record in the database. Right, complete the table to identify the most appropriate data type. Okay. Right, so size in meters, I mean, probably this can be a real, because, you know, probably you can have like 1.5 meters or something. Right, position, first, second, or third floor. I mean, let's say integer. And yeah, actually I'm going to put them in capital letters. Right, hoist. I mean, so this says whether there is a hoist available for the transfer of items. Right, so this is going to be true or false. Okay, so just boolean. Yeah, and I guess maybe I could have capitalized that. Right then, storage ID. So, I mean, text. Yeah, I mean, so I think here they often just say text. Now, in a real database, I mean, you can use text, right? Another one that's actually commonly used is going to be a varchar. So yeah, varchar, well, that's going to, I mean, basically this means like variable characters. So if we did, for example, varchar 20, well, this means that this field can store up to 20 characters, because maybe, let's say you have, I don't know, like usernames. Well, maybe you want a username to have, you know, a maximum length of 20. Right, you wouldn't want someone to have a username of like 1,000,000 characters, because if people did that, I mean, that's actually a common like attack, where yeah, people can actually like upload things to websites. You know, if you upload like a 100 gigabyte file to a website, well, if the website's not doing any sort of validation, then of course, yeah, you're just going to like crash the server. You're going to use up all the storage space. You know, you're going to slow everything down. But yeah, I think actually for IG they don't seem to mention this varchar that often. Right, even though this is what's sort of more commonly used in real life. So yeah, I think for strings, right, just call it text. Yeah, when it comes to database. Right, then we want to complete the SQL query to display only the storage code price and size in square meters of all the storage units where there is a hoist available. Right, so first then we have to think what we need to select, and I mean here it tells us the storage code. So right, let's go storage ID. Right, okay, then we also want to select the price, and I mean, let's just check what that's called. Okay, because if we see here, right, it's not called price, it's actually called price month. Right, so let's go price month. And I mean, you know, you will need to use the exact same names. Right, and then what's the size in square meters? Right, so that's going to be size meters. Right, and then, well, from, so this is then going to be the table name, which I think, yeah, here they say the table is called storage units. Right, and then the condition, well, the condition is, yeah, where there is a hoist available. So I'm just going to say where hoist. And actually, sorry, right, let's make that a capital H, right, since, yeah, you see here it's a capital H. Right, and let's just go equals true. You know, sometimes they do this really weird thing where they go like equals yes, right, or equals no. But I've actually tried this and I can't find any like SQL database where they accept like equals yes, equals no. So I think, yeah, just go equals true or equals false, right, that should be fine. Right, then it says a programmer has written a program that will be maintained by another programmer. Explain how the program can be written to make sure it can easily be maintained by the other programmer. Right, and I mean here they want 6 marks, so probably 3 points, and then, you know, sort of a description for each of them. That should be the 6. Right, so I'm actually going to try and list, because I think usually they list about 4. Right, so one is going to be comments. And I mean for this, right, in the real exam, okay, write in paragraphs, don't write bullet points. However, I'm just doing bullet points, you know, just to be a bit faster. Right, so comments, and we can say, right, to explain, let's say explain previously written code. Let's say to make it easier. Right, let's say to make it easier for a new programmer who has never seen this code before. Okay. Right, okay, so, yeah, again, I mean, probably the handwriting's terrible. But it says, well, comments explain let's say explain previous code to make it easier for new programmers who have never seen code before. Alright, let's say, yeah, never seen. Right, the next one, I mean, we can say modules. Let's say, right, use modules. And then in brackets, right, let's say functions. Right, let's say, yeah, functions / procedures. And well, that's going to be to break up code into smaller, sort of, you know, easier to understand sections. Right, let's say, yeah, to break up. Right, to break up code into, right, smaller, right, / right, more understandable sections. Yeah, I guess, right, more understandable sections that are easier for humans or something. Right, I mean, let's also say it makes code, makes code more organized. Right, let's say makes code, right, more organized. Right, yeah, and easier to test. I mean, let's say, let's say test / fix. / maybe update, right, or kind of just maintain, right, maintenance. Right, so yeah, comments, modules. I mean, we can also probably say indentation. And again, we can say, makes it easier. I mean, I think I'm not going to write this, but let's just say indentation. It will make it easier for programmers to kind of figure out, let's say, the control flow of the program. Because, for example, if you know, well, this is like the outer loop, right? Then you have the inner loop, then you have the inner kind of if statement. Whereas I see sometimes people just do everything like on the left margin. And yeah, when you've got like many loops, many if statements, maybe, you know, different classes, right, things like that. I mean, that's going to become, you know, extremely complex to understand. So yeah, I think indentation again, right, makes it easier to understand the control flow of the program, and kind of, you know, like where things start, where things end, right, stuff like that. Right, and then I guess, yeah, there should be one more. So, right, comments, modules, indentation. Right, okay, and then I think also variable names. Right, so let's see, yeah, meaningful identifiers. And I mean, you know, so some of these are kind of, well, obvious, really. And yeah, I think sometimes people forget this because it's like, well, it just seems like common sense. Like, why would you have to write this? I mean, what this is saying is like, don't just use variables like, A, B, C. Don't use things like this, because when someone else sees this, they're like, well, what's A, what's B, what's C? I mean, I would say the only time where you could use this is probably like inside a for loop. And I mean, I often do this, where you can say, like for n and just, assign this to 1. Because in this case, it's kind of obvious what n is, right? It's just the count variable, right? The index. But I mean, yeah, like if you're talking about like global variables or parameters, things like that, I mean, then you'd want to say, I don't know, like maybe A would be like the name, right? So like name, age, maybe, I don't know, maybe they're, ID, password, right? So just, use meaningful identifier names. And that's going to be for variables, right? But also for constants, for functions, for procedures. Because, I mean, that's what an identifier means, right? Just any of those names. For question 11, the 15 mark, it says students in the class are recording the amount of time in minutes spent in front of a screen for each day of the week. The one-dimensional array student name contains the names of students in the class. The two-dimensional array screen time is used to input the number of minutes on each day spent in front of a screen. The position of each student's data in the two arrays is the same. For example, the student stored at index 10 in the student name and screen time are the same. Right, the variable class size contains the number of students in a class, and we want to allow the students to enter their minutes, their daily minutes of screen time for the past week. Basically 7 days. Right, then calculate the total number of minutes screen time for each student in the week. Right, count for each student the number of days with more than 300 minutes of screen time. Calculate the average weekly minutes of screen time for the whole class. Find the student with the lowest weekly minutes of screen time. And for each student, we want to output the name, the total week screen time in hours and minutes, the number of days with more than 300 minutes of screen time. And also we want to output the average weekly minutes of screen time for the whole class and the name of the student with the lowest weekly screen time. Right, it then says, well, we can use pseudocode or program code, and we have to add comments. All inputs and outputs must contain suitable messages. Student name and class size have already been initialized. And then here, when it says you don't need to declare any arrays or variables, now this only means the arrays and variables, they've declared here, right? But any new arrays let's say any new variables, right, we will have to declare. So what we can do then, again, if you want this starter code, well, click on the exam questions, find February 2024. Now, here I've just commented this, right? We can uncomment if we want. Now, basically, the question we actually have to, loop through and just ask them to input, right? If you just want some test data, because like maybe you don't want to have to input, let's say here, right, like 3 students, 7 days, right? That's going to be 21 inputs. If you don't want to have to, input that every time, well, then of course you can use this test data. And to be honest, like if you do go to the exam questions here, this test data will be random. So, sometimes there'll be like 50 students with, of course, more data. But here I've got 3 just so it's kind of easy to visualize. Right, so, first then, let's just think about the variables we need, because honestly, there's a lot of stuff we need to do for this. So let's go declare, and I think the first one we need, this is kind of the total minutes for the current student. So let's maybe say, total mins for student. Right, we then also need, the total minutes for the class. Right, okay, so enter the daily minutes. So when they enter this, this will be entered, into this screen time array. The total minutes of screen time for each student. So that's going to be this one. Counts for each student the number of days with more than 300 minutes. So let's say maybe num days over 300 minutes or something. And these variable names are quite long, but I think otherwise it's sort of difficult if we use short variable names. Maybe we forget which one is which. So it's kind of good to be descriptive like this. We'll also calculate the average weekly minutes. So I guess the average weekly minutes we can do using this total minutes for class. Right, finds the student with the lowest weekly minutes of screen time. So here, let's call this maybe, lowest All right, let's go maybe lowest minutes, or yeah, I know maybe lowest minutes like student, or I think yeah, just lowest minutes is okay. Yeah, so like, I mean, maybe that's everything, and I mean, if I forgot something, well, I think I'll just go back later and do it. But of course, you know, if we have this lowest minutes, well, here it does say we also need the name of the student with the lowest minutes. So we will also need to declare that. Let's go maybe lowest minutes and name. Right, then this here will be a string. Okay, and then, yeah, I mean, I think maybe that's all we need. Right, so, I mean, let's think about which of these we need to initialize. Now, the total minutes for student, also the number of days over 300 minutes, well, these we just initialize kind of, you know, each time inside the loop. You know, like each student each student we're looping through, right, we would then initialize these to 0. So we don't really have to do this at the start. But I think this total minutes for class, well, we only need to initialize this once, right? So let's do this at the start. This lowest minutes, I mean, some people, you know, they do something like this where they go, let's say lowest minutes, and, you know, set this to some huge value, right? And then of course, well, if the sort of current minutes is less than the lowest minutes, well, then they set the lowest minutes, you know, to be this sort of total minutes per student, right? Which, I mean, that's the current minutes. But I mean, that's not always the best way because, well, I mean, let's say like if the lowest minutes was actually bigger than this. Now, in this situation, obviously it's not going to be, but I mean, let's imagine you're doing data for, I don't know, you know, some scientific data or some mathematical data, and yeah, maybe they have like 50 digits or something. So yeah, I mean, there's actually a better way to do that, and that's to check, well, if the student number is 1, right, so if it's the first student, well, then we set the lowest minutes to be their value. Yeah, else, well, then we compare, you know, if the sort of, if the sort of current total minutes is less than the, you know, sort of less than the overall lowest minutes. So yeah, I'm just going to basically leave that blank, and then I think here, I mean, let's just start looping. Right, so if we look, well, here, I mean, we want to loop until the class size, which in this case will be 3. And then right here, this will be, well, 7, right? That's just, you know, the number of days. So let's call this maybe like student num, and the student number, this will be 1, right? And then we'll just go to the class size. And then, like I said, well, here we just need to initialize the total minutes per student. Right, that's going to be 0. Also the num days over 300. Okay, that's also 0. I think, yeah, that's all we need. Now, I will leave myself space just in case we need anything else, but yeah, hopefully that's fine. Then what I want to do, let's go for the, right, this is the day, right, so let's say day num, this will be 1, and then we'll just go to 7, 7 days in a week. Right, and let's go output, and well, let's output a message like, you know, enter screen time for student 1, day 1, okay, something like that. Right, so enter screen time for, right, so let's say student, this will then be the student num, and let's just go day, and right, then let's just go day num like this. And well, here we can just input this, and I mean, we're inputting into this screen time. Okay, yeah, here we are. Alright, we're inputting into this screen time array. So if we look then, in fact, let's go, screen time. Well, the row is going to be the student number, and the column, right, this will be the day number like this. Now, what we want to do, well, we want to basically add to this total minutes for student. So, okay, yeah, for student. So hang on. Right, I mean, so yeah, here we're just kind of adding to itself. Right, then this is going to be the screen time. And to be honest, I mean, you could have another variable if you want, you know, call it like sort of num minutes. So here you, for example, here you do, let's say like num mins. And then this can be, you know, plus like num mins like this. And then you'd also go, for example, wait, okay, what happens? Right, okay, then you'd also go something like this, and yeah, that's going to be num mins. So I mean, you could do this, you know, with this extra variable, but I think for me, I'm just going to use, the array directly. Yeah, even though I guess, actually to kind of writing this out would be quite slow. So yeah, maybe it is better to use just a temporary variable in the exam. Right, so what we want to do then, let's go if, because, well, we want to check if this is bigger than 300. So yeah, why does it keep doing that? It's just jumping to the top for some reason. Right, so if this is bigger than 300, right, then what we want to do, we just want to increment the number of days over 300 minutes. Right, and then yeah, is there anything else we need to do for that? No, so I think, yeah, we don't need to do anything else in there. Because, well, we've done this, right, counted the number of days with 300 minutes, well, more than 300 minutes. And we've also calculated the number of minutes, yeah, for each student. Okay, so right, let's try the next one. Okay, calculate the average weekly minutes for screen time of the whole class. So right, that's going to be just adding to this. Now, I mean, we could do it in here, so we could go something like total minutes for class, then total minutes for class, and then, well, plus, the sort of current, the current day's minutes. But the problem with this is, well, I mean, here we've got, well, like 3 students and then, 7 days. So effectively, we're just doing this addition like 21 times. So I'm actually going to copy it, and then, well, if I just go next, right, so let's close the for loop. Right, then I'm going to paste it here. But then in this case, right, this won't be the screen time, because remember, this is only for 1 day, right? What we want is, well, we want to add this total minutes per student, because, yeah, this will be their total for 7 days. Alright, so yeah, that should be identical. And then, right, we want to find the student with the lowest weekly minutes. So, like I was saying, what we can do, we can check if the student number is 1. And then if it is, we'll set this to be the current lowest minutes. So here the lowest minutes, this is the total minutes per student. And let's go lowest name. Right, and then this is the student name array, and then the index is the student number. Right, but then we want an else, and okay, there we go. Right, this is where we do the normal way of checking for min, checking for max. So we just say, right, if the total minutes per student is less than the lowest minutes, right, then what we're going to do, we're going to set the lowest minutes, and yeah, this will be the total minutes per student. Right, and we also need to remember to set the name as well. So just like before, this is the student name array, and then yeah, the index is the student number. Alright, so I think, yeah, okay, so well, let's recap. So allows the students to enter their daily minutes, yes. Okay, calculate total minutes of screen time for each student in the week, yes. Yeah, okay, yeah, we've done that. Right, count the number of days, yeah, okay. Right, calculate the average weekly minutes, yeah, we just did that, right? Yeah, so we've done that here. Well, I mean, okay, so, I mean, we've calculated the total. I mean, yeah, the average we'll do at the end. Right, so find the student with the lowest weekly minutes. Yeah, we've done that. Outputs. Right, so here then, let's just output this for the student. And, I mean, the name is easy, right? The number of days more than 300, well, that's also easy because, we've calculated here in this for loop. The sort of slightly tricky one is, well, we want to output the screen time, but in hours and minutes. So let's think we have maybe 150 minutes. Well, what we want to do, we want to convert that to 2 hours and 30 minutes. Now I'll give you 5 seconds. Try and pause the video. Right, have a think about how you can do that. Okay, so maybe you've realised. I mean, here we can just use div and mod, because let's say if we do well, I mean, let's just write it here. Right, if we say div, let's go 150 div 60. Right. Then hopefully you realise this will equal 2, okay, this will be the hours, because we're saying, well, if we have 150 minutes, this can be kind of like wholly divisible by 60, 2 times. Right, and then if we go, let's say mod, right, this is again 150 and, right, 60. Well, this is saying, what's the remainder after we've divided by 60, and in this case, well, this will be 30. Because obviously, well, we can divide by 62 times, right? So, well, that's going to be 120. And then, of course, well, 150 minus 120, right? That's, 30 remaining. Right, so yeah, I mean that's how we can output this. So let's just go right here. And what I'm going to do, I'm going to output the name and then I'll say screen time. So, right, this is the student name, this is the student number. And let's maybe have a apostrophe like this. And yeah, let's just go screen time. Right, and I mean here again, you know, we could have more variables if we want. However, I think I'm going to do it, yeah, just on one line. So right, let's say, yeah, div. Right, this is the total minutes for student. And yeah, we're dividing this by 60, right, and then let's just say hours, and then here, well, this is going to be mod, this is the total minutes for student, and yeah, this is going to be 60. Yeah, okay, and then, well, then let's just go minutes like this. Right, then we also want to output the number of days over 300. So let's go, yeah, days over 300 minutes. And then this is the, yeah, num days over 300 minutes. Okay, so I think, yeah, I think that's everything. Then we just want to output these, so the average weekly minutes for the whole class. Okay, so let's just go, yeah, next, yeah, okay, so next student num. Right, so the minutes for the whole class, let's go output. Yeah, to be honest, right, I'm actually just going to add a separator, right, just so we can kind of see the difference between, let's say, you know, the student values and then the total values. Yeah, let's also add a new line between each student as well. Right, so let's say, yeah, average, maybe average minutes for class. And I mean, here they don't say we have to round it, so I think we could just divide it directly. Right, this is the total minutes for class, and then, well, divided by the class size. And yeah, this total minutes per class, I mean, this should work. Right, then the next one, right, the name of the student with the lowest screen time. So let's say, yeah, student with lowest screen time. And then here, this is just the, well, the lowest minutes name. Right, so, yeah, hopefully this is everything. Yeah, I think that's everything. So let's just run it and see if it works. Okay, so yeah, enter screen time student 1 day 1. Let's say, I want to think of some like easy values. Let's say 60. Maybe let's say 120. Right, let's say 180. Right, let's say maybe 240. Yeah, although to be honest, actually these are not that simple. Right, let's go 300 and 360. And wait, hang on, did I double enter? Okay, no. Alright, so yeah, 420. Right, so I mean, here it says 28 hours. I mean, yeah, days over 300 minutes. Well, I mean, the days over 300 minutes, that seems correct. Okay, these 2 days. I mean, 28 hours. Like, I guess we've got, what is it, 240. So I think, right, this is the average because, well, you know, these are less, yeah, sort of these are more. You know, for example, this is 60 less, this is 60 more, this is 120 less, yeah, 120 more. So I think basically this is just 4 times, because, yeah, so 24 is 4 hours. Yeah, although, yeah, okay, so I think, yeah, I think that's correct. You know, I thought it wanted the average, but yeah, this is just the total. Right, and then, I mean, honestly, like, we can just do the same. So let's say maybe 100, let's go 200, let's go 300, right, 400, yeah, 500, 600, 700, and then maybe the last one, I mean, well, let's check if that works. I mean, 46 hours, 40 minutes, like, probably that's okay. I mean, let's try something simple. Let's just go 10, kind of all 10s. Right, so if we think about this, well, this is 1 hour, 10 minutes, and we can see that's correct because, well, 10 times 7, 70 minutes, right, that's 1 hour, 10. Yeah, days over 300, right, that's 0. I mean, average minutes per class, yeah, probably that's correct. And then, well, Matteo, and yeah, they're this guy, right, just 10 minutes. Now, I mean, let's just test this quickly. So let's go maybe 10. And I mean, yeah, there is a lot here, to be honest. And then maybe let's just say like 20. Right, and then let's just go 30. Okay, so here what it should say, the average is 20 minutes. Right, average minutes per class 140. So is this... Okay, yeah, so I guess this is fine, right, because this is the weekly minutes. Alright guys, so I mean, I think, yeah, this seems to be working. Now, I will actually check the mark scheme, you know, just to make sure this is correct. Yeah, I mean, hopefully there's no sort of, you know, strange behavior. Right, now, if you do actually want to use the test data, you know, because maybe you don't want to have to input like hundreds of values each time, well, I'm just going to uncomment this. And then what I'll do is, I guess, well, rather than just inputting like this, yeah, like now basically, I mean, this should just work, hopefully. Alright, so now if we just run this, yeah, I guess it's saying what average is this. Again, Matteo is the lowest. And if we look at this, I mean, yeah, right, this seems to be correct. Okay, guys, so again, I mean, hopefully this makes sense. As always, if it doesn't, well, yeah, ask in the comments, ask on Discord, and see you in the next video.